Bismillahirrahmanirrahim. In the first part of this section, which is the derivative function, we gave the definition and we said that the derivative of f prime equal to the limit of f of x plus h minus f of x divided by h. In that part, we said that the derivative f prime of x equal to the limit of f of x plus h minus f of x divided by h, where h goes to 0. And we say this is the derivative of a given function. Or sometimes it's called the change of rate or slope of the tangent line. And we gave different examples how to find the derivative using this definition. In this part also we are going to give more examples and we need to find the derivative using the definition. Find prime of the function using the definition. Or the first principle. We said that we call it the definition or the first principle. Say, for example, number 1 for today, f of x equal to square root of x minus 1. And I want to find the derivative of this function. F of x equal square root of 2x minus 1. Let's find first f of x plus h. Replace any x in the given function by x plus h. So I will have square root of 2 multiplied by x plus h. Replace x by x plus h minus 1. That will be square root of 2x plus 2h minus 1. This is f of x plus h. Now the derivative is equal to the limit of f of x plus h minus f of x divided by h, where h goes to 0. This is equal to limit of f of x plus h is given by 2x plus h minus f of x is square root of 2x minus 1 as h goes to 0. Now this is of the type 0 over 0 indeterminate case, so we need to simplify it. And to simplify, a function contains some radicals, just multiply by the conjugate. So let's multiply this by the conjugate. Conjugate is just the same value of the numerator, but we need to change the sign. So the conjugate is square root of 2x plus 2h minus 1 and square root of x with different sign. It is plus. It was minus, now it is a plus. And this to be written up and down. 2x plus 2h minus 1 square root of x with the sign plus. Because this is the conjugate. This will give me the limit of the first part square, first term square minus the second term square. It is a plus b multiplied by a minus b. 2x plus 2h minus 1 square and square root of, sorry, the conjugate is not square root of x. It is 2x minus 1. It is this part, 2x minus 1. So this is 2x minus 1 square divided by h multiplied by 2x plus 2h minus 1 plus square root of 2x minus 1 as h goes to 0. This will lead to limit of 2x plus 2h minus 1, because the square root will cancel with the square. Same thing with the second term. Minus 2x minus 1 divided by h multiplied by square root of 2x plus 2h minus 1 plus square root of 2x minus 1 is equal to 0. To simplify, if you open the bracket, you will see that 2x will cancel 2x. Minus 1 will be cancelled with the minus 1 in the second part. So this is the limit of 2h divided by h multiplied by 2x plus 2h minus 1 plus the square root of x minus 1, where h goes to 0. And it is very clear that h is a common factor between the numerator and the denominator. So this h will cancel this h. So it is 2 divided by square root of 2x plus 2h minus 1 plus square root of 2x minus 1, where h goes to 0. Now if we replace h by 0, this will be 0. So the derivative now, f prime x equal to 2 divided by square root of 2x minus 1 plus square root of 2x minus 1, which is equal to 2 divided by 2 square root of 2x minus 1. Or just I can also take this 2 with the 2. I will have derivative is equal to 1 over square root of 2x minus 1. So the derivative of this function is equal to 1 over square root of 2x minus 1. We just applied the definition to find the derivative in this case. Let's take one more example. Number 2. F of x equal to 1 over x. And I need to find the derivative of this function using the definition. F of x equal to 1 over x. So let's find f of x plus h. That means replace an x in the given function by x plus h. So I will have 1 over x plus h. Now find the derivative. Which is limit f of x plus h minus f of x over h, where h goes to 0. This is equal to limit of 1 over, or I'm sorry, f of x plus h is 1 over x plus h minus 1 over x over h, where h goes to 0. Now combine the two fractions by cross multiplication to find the common. It is just multiplied these cross multiplication to come up with a common denominator. So this is equal to limit h, I will write it down as it is. For the numerator, I have x multiplied by x plus h. This we multiply this part, this x with x plus h. Then x multiplied by 1 is x minus 1 multiplied by x plus h, it is x plus h. This one with this part, this one with this one. So I have x multiplied or x minus x plus h and x or divided by x multiplied by x plus h. All of these will be divided by h as h goes to 0. Which can be written as limit these will be multiplied together. So I will have x minus h, this is the numerator, divided by h multiplied by x multiplied by x plus h, where h goes to 0. So x will cancel minus x. I will have only minus h. The numerator. So this is the limit of minus h divided by h multiplied by x plus h as h goes to 0. H will cancel or will be cancelled with h. Then I have minus 1 divided by h is equal to 0. This one, if we replace h by 0, after we simplify the first h, I will have x multiplied by x. So it is x multiplied by x. So we say that the derivative now in this case is equal to minus 1 divided by x squared. So the derivative of 1 over x is equal to minus 1 over x squared. This should be clear. The derivative of 1 over x equal to minus 1 over x squared using the definition.